Hello everyone, welcome to my channel. Today we'll be discussing chapter number 17 of Claydon Solution Manual, Elimination Reactions. Let's begin with this problem. So what is the product formed here? First of all, the lone pair in the nitrogen atom is going to attack in the methyl group. Then since iodine is a good leaving group, so it is going to leave, and we get the product as N trimethyl, and there will be generation of positive charge. Now in the next step, base is given sodium hydroxide. So this base will abstract a proton. So now which is the most acidic proton here? This one or this one? This one is the most acidic proton because after abstracting this proton, this will undergo conjugation. So it will abstract this proton and it will give us double bond O minus and here N Me3, okay, and a positive charge. So now in the next step, this negative charge will come here and this bond will migrate here, and since Me3 becomes a leaving group, so it will leave and it will give us our product as double bond O, and double bond. So this will be our final product of this reaction. Now let's move on to our next question. In this question, this product is from this reactant when bromine is below the plane, but this product is not formed when bromine is above the plane. Now let's see why it is so. For this we have to draw the chair configuration. So this is a chair configuration and over it electron ring is there. So let me draw the electron ring. 1 2 3 1 2 3. This is the electron ring and the bromine is attached in the side carbon and it is below the plane, so it is axial. And when a base is added, it is going to abstract a proton, and it will abstract a proton in such a way that a double bond will form, and since bromine is a leaving group, so elimination will also occur. And for the double bond formation in a chair form, it has to be anti-periplanar. Okay, the leaving group has to be in the anti-periplanar position, diaxial anti-periplanar. So it will abstract this proton and this bond will go there and this group will leave. We get our product as double bond will be there and the electron ring, and this structure is equivalent to this structure. For this case, this product is not formed. Let me draw the chair form again. Now let us check for this one. Okay, electron ring is there and bromine is this time above the plane. It will be in the equatorial portion and there is hydrogen, axial hydrogen. Now in this case it is in the equatorial position, so the base, though it can abstract a proton, but elimination cannot take place here because it is not diaxial. So it is not anti and it is not diaxial also, so elimination will not take place, and so we are not going to get this product from this. Now let's see this question. So what is the product formed here? To get the product, we have to write this one in the chair form. So bromine, first of all, it is the bulky group, tertiary butyl group is the bulky group and it is above the plane. So put here the tertiary butyl, since it is bulky group, so it will be in the equatorial portion. And now 1 2, at the third position there is a carboxylic acid above the plane. So 1 2 3, we put a carboxylic acid above the plane, and in the side carbon again one bromine atom is there, it is also above the plane. Okay, now a base is given, suppose. Okay, what is the role of base? It is going to abstract a proton. Now which proton it is going to abstract? Since there is a leaving group present here and it is also two axial hydrogens are present, which hydrogen it is going to abstract? This one or this one? Let us consider this hydrogen is abstracted. On abstraction of this hydrogen, there will be a formation of a negative charge here. Okay, a negative charge will form here, but this negative charge cannot be stabilized here since no electron withdrawing group present here. But in this case, on abstraction of the proton, a negative charge will be there. Okay, and this negative charge will be stabilized due to the presence of an electron withdrawing group. Okay, so it will be stable. So this hydrogen will be abstracted, and thus it is anti-periplanar. So this leaving group is going to leave, and we are going to get our product as double bond will be there, and carboxylic acid and tert butyl. It is equivalent to, it can be written as, this is the tertiary butyl group, and since carboxylic acid is there, carboxylic acid and a double bond here, so it will be the product formed here. Let us see what product is formed when the same reaction, means this time in the previous one it was above the group, above the plane. Now in this one it is below the plane. Okay, now see what is the product formed here. First of all, tertiary butyl above the plane in the equatorial portion, then this time carboxylic acid is below the plane, and bromine is above the plane. Now this time also the bromine is a good leaving group here, and it is in the axial position, so it is going to leave. But this time there is no axial hydrogen, so this time what it happens, the base is going to abstract a more acidic proton, right? So it is attached to oxygen atom, this hydrogen. So this negative charge is going to abstract this proton, as it is more acidic, and negative charge will be in the oxygen atom. Okay, so negative charge will be in the oxygen atom. Further, this negative charge will go there, and the negative charge will further be in the carbon atom, and there is decarboxylation. Carbon dioxide is going to leave. Okay, so and then this negative charge is going to go there, and bromine will leave, and thus giving us our product as double bond. Okay, so it is equivalent to, this will be our final product, the tertiary group and a double bond here. This is the final product of this reaction. Now let us see an easy question. There is a double bond, there is a triple bond. Now hydrogen, when palladium and calcium carbonate is given, this is what catalyst? What is the name of this catalyst? It is Lindlar catalyst. LINDLAR, Lindlar's catalyst. Okay, what is its function? It converts triple bond to double bond, and also gives us a cis alkene. Remember this one. Okay, so the product of this reaction is going to be OMe OH pH. So this is cis position, so this will be the product of our reaction. See, and another question. So what is the product formed here? Now first of all, since there is a possibility of formation of 6-membered ring, 1 2 3 4 5 6. Okay, so the lone pair on the oxygen atom is going to attack at the carbonyl carbon, and negative charge will be in the oxygen atom. Okay, it gives us O, and here double bond O is there, here O minus, and pH, there is a OH, it is positive in charge, right? So this positive charge, and now it will, this H plus H will remove, and this negative charge is going to abstract this H. Okay, then it gives us pH, and here OH, double bond O. Further, since H plus is given, so this OH, the lone pair on the oxygen atom is going to abstract this H plus, and we are going to get OH2 pH. Now OH2 is a good leaving group, right? So the lone pair on this oxygen atom is going to get here, and OH2 will leave, and we are going to get double bond, positive charge, and here pH, and here double bond. Further, positive charge is on the oxygen atom, so H will remove here and positive charge will be neutralized, and we are going to get the product as, and the product formed is PH double bond O double bond. So this will be the final product of this reaction.